Hello everyone. I welcome you all for the session on LED using PIC16F877. So let us have this as a case study. So we have discussed in the previous session, we have discussed about the pin description or the signal description of 16F877. That is about the IO ports specifically. How the IO ports are being accessed. What are the IO signals or IO pins available? Which are the pins to be enabled if we want to access the PIC microcontroller using these IO ports. This is what we have discussed, and in continuation with that, let us discuss about a case study on LED. If I want to glow an LED, my problem statement here is to glow an LED using the PIC microcontroller 16F877A. So let us have a brief discussion on GPIOs, that is general purpose input output pins of PIC16, general purpose input output pins in general, and also which are available with the embedded trainer kits of PIC16F877. What are the common outputs available here are LED, LCD and 7-segment display, which commonly are inbuilt in a normal trainer kit or development kit. And the inputs available will be keypads as well as sensors. Sensors could be of any kind. It could be analog sensors or it could be digital sensors too. And how this GPIO structure looks, we are going to discuss about if I want to access these inputs and output devices, which we have discussed now. It could be, if it is an output, it could be a 7-segment display, it could be an LED, or it could be a LCD, or other than this, it could be a motor, stepper motor, or a DC motor. Any other output devices as well as input devices can be connected. So if I want to connect these IO devices, then how to access these ports? We have 33 port pins, general purpose IO port pins, and how I can connect these IO devices to those ports. That is what we are going to look into here. For this, we basically need two registers. One is port registers and the second one is TRIS registers, TRIS registers. So if you see, PIC16F877 is an 8-bit microcontroller, and so all these registers also has 8 bits. So here if you see, this is the general structure which has 8 bits. Now coming to the TRIS register, TRIS register. So what is the function of this TRIS register is, we have 5 ports. We know that port A, B, C, D and E. Altogether 5 ports and 33 pins are available. See, these 5 ports, all the 5 ports can act as input as well as output. Every port can be used as input or output. So it is our duty to mention or to specify or command the microcontroller whether that port is going to be used as an input port or output port. That is the direction, whether I am going to give inputs into the controller or whether I am going to get output from the controller. This is which I need to mention to the mic or specify to the microcontroller. For that, we require registers, and those registers are known as TRIS, tri-state registers, TRIS registers. In short, TRIS registers are used to show the direction of the ports. Now, TRIS register is again an 8-bit register, because PIC microcontroller 16F877 is a 8-bit microcontroller, and so these registers also will be 8-bit. Suppose if I want to access a particular port, that is here for example I have given that if I want to access 0th bit as input, then how will I access this? See, if it is input, then this bit, if I want to access this bit number 0, then this bit has to be made 1, or we have to enable the bit. That is, it has to be made 1. If I want to use that as an output, then we'll be disabling the particular bit of the register. So simply by enabling and disabling the registers, we can access these ports. So if a particular bit is being enabled, or if it is given as 1, it means it is input. If it is 0, then it means that it is an output. So here, in the previous case, we have discussed about 1 bit. Suppose if I want to access all the bits of a particular port, then see, if I want to access all the pins of port C as output port, then all these 8 bits has to be made as 0. So when I am mentioning it in the program, then I have to mention as tris C port, TRIS C port, 0th bit is 0. It means that this pin will be acting as an output pin. Similarly, this pin, every individually I am telling that all these pins are output pins. So when I am mentioning it in the program, I will be mentioning as I am setting the register as TRISC is equal to, that is tris of port C register is equal to all 8 zeros, and this 0B denotes that I am giving a binary input. That is the meaning of the 0B. So 0B, all zeros. It means that the C port has been used. We are going to use this C port as an output port. So I'll be connecting a 7-segment display or an LCD display or a motor or anything to the output devices to the port C. Now, FIA thought, suppose if I want to configure 0th pin of port B as output pin and rest of all the port B pins as input pin, that is only this as output pin and all the remaining as input pin, how will I give the value? So this is how we will be giving. Only this will be 0 and all, since it is input, we will be giving us 0B, all ones and zeros. Now, normally in a program, when we are mentioning, we will be using hexadecimal representations. How to represent this? So suppose for the previous thing, see 0B and bit 0 is output and all the remaining are inputs. So now convert this into equivalent binary, hexadecimal value. So the value will be F and E. When we are representing a hexadecimal representation, then we will be giving a 0x. This x denotes hexadecimal. This representation is a hexadecimal representation. If it is binary, we will be mentioning it as 0b. So, if you see here, now see, I am telling that the port B register, the port B is hexadecimal FE. FE in the sense, F is all ones and then 11110. So here through hexadecimal representations we are denoting whether the port is an input port or an output port. This is also thought. For if I want to make a third bit and fifth bit of port B as input and rest all other as outputs, then what will be the hexadecimal value? So it will be 28. Now, once after setting the tris registers, we have to set the port registers in the same manner. The same way we will be representing the port registers too. As we know that we have 5 ports and port A has 6 pins. Port B, C and D has 8 pins each and port E has 3 pins each. So this is the register setup for accessing the ports. If I want to access port A, if it is first pin, then I will be enabling or disabling that according to this RA0 accordingly. So if I want to make RB3 pin as high and all the other ports as low, then we'll be making it as high and all the other as 0 and I'll be representing. So only this is being made high and all the other 0, and so I am mentioning that port B is hexadecimal 08. It means that I am accessing only this pin, only RB3 of, so RB3 I can connect an LED. In pin number port pin RB3, I will be connecting an LED, or through the pin I will be connecting some other device through the single pin. So every single pins can be accessed by this method. Now let us take the case of blinking an LED. So see, In the pin RB7, we have connected an LED. So this is my microcontroller RB7. I have connected an LED. So how the code looks like? We'll be including all the header files. This hash defined crystal is, since I've used a delay here, we'll be using this macros too. And now see, I've defined the tris register, and then in a loop I'm telling that enable RB7, that is make the RB7 high, that is blink, the LED blinks, and after a delay of 1000 milliseconds, this is an inbuilt delay, then the LED will be off. Then again, this is an unconditional loop, then again after 1000 milliseconds, LED will be on, then again it will be off. So this is by toggling this on and off, we will be making an LED to blink. So see, this tris register is not going to change once if it has been set. So we are defining it out of this while loop. So now this is a small code to show, this is a case. If I want to glow an LED using this tris registers and port registers, how to access. And this is for your assessment. And thank you.